Good afternoon, everyone. I'm Jeremy Picot-Clement, Photonics Technology Manager at EPIC, and I'm really pleased to welcome you for this first online meeting after summer, a product release online meeting. So I hope that you enjoy your holidays if you get some and are ready to go back to the technology after the summer break. So today we welcome 4 companies which will present their new product, OPTOMAN, Microlam, Synopsys, and a workshop of Photonics. And I would like to also to remind you that it's a live event, so feel free to ask any question you will have in the chat or by raising your hand through Zoom. So what is EPIC? Just a quick reminder, EPIC is the largest industry association with more than 800 members working in the field of photonics. We try to act as a catalyzer for the photonics ecosystem by maintaining a strong network interaction between our members by organizing physical and online events, but not only, since we publish market and technology reports, organizing technical workshop, and with a lot of other activities you could find on our website. And here you can see the EPIC team made of 14 people, all passionate by photonics. This team manage and support all the ecosystem with their technology knowledges, market reports, proactive networking by organizing physical and online events, as I told you, and also easing the market access to our members, also in HR with specific website dedicated to the jobs in photonics and supporting the development and the investment in this industry. So here are our panelists of this today's event. So we'll start with Kode, product development engineer from Microlam. Second position, Quentin Kuperman, AE manager at Synopsys. Konstantinas Zakalskis, business development manager at OPTOMAN. And we will finish this event with Lukas, Kulikauskas, product owner at workshop of Photonics. So now, Sai from Microlam, if you want to share your presentation, and you can start.
Sure.
And yes, it works.
Works perfect. All right. Oops. Hello, everyone. So for this presentation here, we're just going to go over a quick overview of about Microlam, about the Optimus in general, and then how this is going to be useful in the future for manufacturing of glass A spheres. I'm the technology lead for Microlam, and I've been with the company for about 10 years now, almost. Yep. So the Microlam started with providing a retrofittable tool post for the diamond turning industry specifically, which is ultra precision CNC, useful in optics manufacturing. Since then, we've been able to sort of pioneer the product further and further, and along the way, we've also acquired other companies or started other companies, such as M10 Edge in the UK and 603 Optics. Both these companies combined give us a very sort of vertical integrated platform for diamond turning, being able to provide you tooling support, custom tooling design, as well as even specialty optics manufacturing through 603 Optics and prototype optics production. So overall, sort of, it's the go-to company for diamond turning of any sort. And just to tell you a little bit about the Optimus so far, it's been sold over 100 systems worldwide, primarily in the use in the infrared industry, as well as consumer optics manufacturing industry is another big market for us. So with this, it's a quick system retrofitted on the diamond turning machines, and able to improve yield from existing processes. Now, the way this all works is by utilizing a laser. And what's different about us in general, or the Optimus portion of Microlam, is that we're able to implement a laser coming through the diamond, precisely through the diamond, right at the cutting edge, which then changes the material properties right where the diamond and material interface together. making it softer. And the diamond is still the tool that's primarily doing the cutting. In doing so, the laser is effectively able to soften the material sufficiently to provide all the benefits of faster machine time, better yield, a more ductile process, and this slight added heat in the process that we impart is also removed in the form of chips coming off. Therefore, we do all of this without really changing the bulk properties of the material that we cut. This is a patented system, and we're the sole sellers of these sort of special tools specifically used on the Optimus. So the new thing that we're coming up with is we're calling it BOLT, better optics through laser turning. And essentially, we have a vision to be able to diamond turn glass. Previously, diamond turning glass was not possible. But looking at the current challenges of the traditional methods of grinding, where you have forms on glass much larger than you could with more deterministic processes such as ultra precision CNC or diamond turning, we hope to improve the existing way to produce glass through better form, better surface roughness achieved, in the pre-polish stage. This direct diamond turning of glass also imparts much less subsurface damage as opposed to the current grinding processes, and therefore eventually minimizing the polishing time. And not only that, because of the unique way of cutting glass using the diamond tool, we're able to add some of the features that a diamond turning machine would be able to, other than a grinding tool, such as mechanical features, more complex A-sphere freeform capability. If we have inflection points and so forth, it should be no problem for a diamond turning machine, and therefore just overall easier to produce more complex glass optics for the future. These couple slides are just examples of some of the preliminary results we have, and I'll explain the picture on the left first. The one on the very left is a rough ground sample coming off a generator, and then just to the right of it is a diamond turned sample. And then to your right, you have another couple examples of a fine ground sample, and then once again, the diamond turning sample to the right next to it. And you'll see clearly that there is a difference in transparency, if you will, between both these samples, providing you a visual indication of the subsurface damage that the other existing processes create versus the subsurface damage that we impart. It's quite a bit less. Currently, our focus as a company is to be able to target the fused silica and BK7 materials with diameters ranging all the way from 5 to 50, center thicknesses of anywhere less than 40 millimeters, a sort of manageable aspect ratio for these lenses, and then R numbers greater than 1.5 and so forth. And we will be able to get down to irregularity of lambda by 4 or 150 nanometers roundabout once we're done with the final polishing steps. So you would ask, why do this and why change the current way that's being done? So especially now with quite a lot of increase in glass prototyping needs and so forth, the lead times with the existing glass manufacturers have really gone up. Could be anywhere from 12 to 24 weeks, depending on your material type, how complex this is. And this new approach allows us to get lead times within 6 to 8 weeks, which allows you to have more cycles for initial prototyping and therefore be able to eventually deliver to market faster using the service that we would provide. Essentially, right now, if you go through conventional processes, your precision glass molds can be 35,000 or more, and then trying to build several prototypes would just be more and more cost. Eventually, that would come down, and the big advantage is the better swap or size, weight, and power performance using our method. And yeah, that's all I have.
And thank you very much for this interesting presentation, Sai. And we have already one question from Leonardo Aguirre Teledyne. Please, Leonardo.
Yes, thank you, Jeremy. Yes, thanks for the explanation of how actually the products work at your end on Microlam. The question I have is there any sort of relation between the quality of the laser to perform better on the obviously CNC machining that you're doing at the end product, and more related of the quality of the laser is obviously the power source that are generating those lasers?
Yeah. So the current laser supplier that we have a very high-end, reliable laser source that is very stable and rated for a very long lifetime, essentially 100,000 hours of continuous use. Because of some of these factors, the existing laser we use is certainly a very capable one. I will say that one of the aspects that we are exploring as a company are different wavelengths. So currently, the lasers that we use for the existing infrared markets and even glass for the time being is a 1 micron laser. Different materials behave and respond to lasers differently at different magnitudes. Therefore, varying the wavelengths of the lasers may certainly help, and that's something we're looking into.
Okay. Yeah. Sorry, one more question. Is the variation of the wavelength are related to the power source voltage-wise or different other technology?
No, this is completely different.
Thank you.
Thank you, Leonardo, for your question. Thanks, Sai. Do we have any other question? Maybe I have one for you. Well, okay, 2 questions. We'll give you the voice to, okay, Konstantinas, if you want to ask, please.
Yes, thank you. Interesting presentation, interesting approach. This is very nice, to make subsets like this. I wonder, this scratch and dig 40-20, this is before polishing. This is what you get just after you do this diamond turning.
No. So the diamond turning gets it to a pre-polished state.
Okay.
And as you saw, the transparency was much better. We, at Microlam, will actually offer the full service where we will polish the lens as well, so that customers then are able to give us, the prototype optic in its final prescription, and we'll be able to deliver to them the final optic.
Okay, thank you.
Yep.
Thank you, Konstantinas. And a question from Kestutis from ARO.
Hello. Thank you for the nice talk. Could you please elaborate a bit more how the surface quality of polished fused silica substrate is better than compared to other conventional techniques?
So our technology actually replaces or enhances the existing grinding. The eventual polishing is actually still just as is. You would still polish with the existing machines out there.
Yes.
Therefore, our technology allows you to get the optic in a state that's very near polished, where the polishing machine now has to do very little work. But eventually it's the polishing machine that will define the final surface that's on the lens.
All right, so basically it does a grinding, that first pre-polishing stage, and is somehow better than the conventional methods, right?
Correct.
All right, any results to prove that? Let's say lower density of subsurface damage or something like that, or laser damage?
Oh, absolutely. Yeah. So we've been gathering varying results in this past month/year of diamond turning of glass that we've done. And in the future, when we have those results available in a format that we can present, we will get that out there as well.
All right, that's very waiting. Thank you.
Yeah. The first sort of preliminary teaser, if you will, were those pictures of just the comparisons of the surface finishes that you get using these different processes.
Thank you.
Yep.
Thank you, Kestutis, for your question. Thanks a lot. Okay, maybe one more from my side. Just I would like to know if you have some limitation in terms of shape or geometries for this prototyping.
Yes. So some of this, similar or same limitations would apply where very thin lenses, mounting very thin lenses is always a challenge fixturing wise. There's always potential for chatter. Very steep slopes, such as hemispheres, they might be challenging. And you have to keep in mind this, because it replaces or augments, I should say, grinding or generating. It does not replace polishing. So eventually all the limitations for the final optic have to be determined by whatever limitations exist currently in polishing. And then prior to that, we're able to get the optic to a state where it's near net polished. So some of those limitations will still apply. Like one of the numbers you saw on the slide, currently we want to focus on R numbers close to 1.5. If you get R numbers, much smaller than that, it's a more challenging optic to produce.
Yeah, sure. Thank you very much for your answer. Thanks again for your presentation, Sai. And yeah, we can move forward with the next presentation from Synopsys. Quentin Kuperman, please, Quentin, if you want to share your presentation and start. Thanks again, Sai.
Here we are. It's fine.
Yes.
Yep.
Perfect.
Well, then let's start, and good afternoon to everyone. I'm very glad to be here and have this opportunity to present our new product here named TIS Pro, which is a dedicated instrument to measure total integrated scattered light, and that comes right next to a portfolio that we already have. And so I'm very thankful to EPIC for this opportunity. Let's start with a small, very brief introduction of the company. So I work at Synopsys, actually previously at Lightech, and we were acquired 2 years ago by Synopsys. So Synopsys is a US-based company, worldwide leader in electronic design automation tools and services providers. So they basically develop, and we develop software to design electronic design automation. And as far as I'm concerned, actually, among that big Synopsys family, I work in a smaller group, the Optical Solutions group. So as you all know, electronic and optics are getting more and more, working more and more together. And so we are part of this new, this Optical Solutions group within Synopsys. And this group is dedicated to developing software to do optical simulation ray tracing. So we have many different software, which I'll just mentioned briefly here, but I'll focus on hardware and our new product. So those software are here to help designers in their conception of projects, virtual conceptions of products for imaging optics using Code 5, illumination optics using light tools, automotive lighting design using Lucid Chip, and photonics device design using RSoft. And so why I'm here today is to speak about that actually 6 field of application of optical solution groups about the optical scattering measurements. So Synopsys acquiring Lightech 2 years ago was mostly for our hardware capability of doing optical scattering measurements. I'll focus on that and the new product that we have. I'm located in France, and in this French office, we have a lab fully dedicated to measure optical scattering on surfaces and materials. So basically, we just shoot some light on surfaces, materials, and we are looking where the light is going. And this is used by optical designers or plastic, aluminum, diffusive sheets manufacturers in their everyday life to get info on what they're designing and what they're manufacturing. So applications are extremely wide. Automotive is a big one, display, aerospace, and some others. Today, our existing portfolio are those instruments, the 3 instruments that are dedicated to what we call BSDF measurements, meaning looking to the angular scattering of the surface. So we have 3, MiniDV2, which is our entry product, MiniDV Pro, which is kind of a laboratory version of MiniDV2, and our high-end product called Reflect 180S, which is more of it's a goniometric solution compared to the 2 other ones that are camera-based. So all those 3 instruments are not the new one, actually. Those are existing ones from many years, and only considering where the light is going. And the needs for those are, I'm mentioning 3 here, but there could be way more. Of course, the first need is to set accurate optical properties for designers in their optical simulation software. You could use those to do R&D and to design the right material, or you could even do some quality control on your in your manufacturing process. I mean, in the beginning of the day, what gets out of your manufacturing process should be the exact same as what's going out at the end of the day. So our solutions are used for that and to control the optical scattering. And on top of those 3 instruments looking to the angular optical scattering, now today I'll focus very quickly on the new one, the new baby of this instrument portfolio, which is called TISPRO, which works very closely with the 3 other ones. And that's a solution that we have had in our lab for, I mean, since the beginning, but we decided to make it available for users of our other instruments. And they work very closely together. The 3 previously existing ones are looking to the angular spread of the light, where the new TISPRO one looks to the amount of light propagation, wherever the light is going. And so it basically measures reflectance, transmittance, and absorptions values of surfaces of materials. And one of the key things of this new product is, of course, the spectral dependency that you can find on other solutions. But one more key criteria is rather the angular dependency. You may find many solutions measuring RTA and absorption values on the market, but almost all those ones are focused on a single angle of incidence, so only single light direction on those materials. And our solution here offers the opportunity to have an angle dependency measurements. The principle is extremely easy. The but that's what our instrument is intended to. And it's a good thing that it's easy to use too. So we have, of course, a calibrated standard and guided procedure that comes with it, with the instrument, to make sure that you get the most accurate measurements. The key thing here for the Angular dependency is about the custom sample holders and the automated source. So all this is controlled by your software, and out of it, you get the spectral dependency and incident dependency of reflectance, transmittance, and absorption of your surfaces and samples that you want to characterize. The high dynamic measurements allows you a wide range of samples measurements, from mirrors for the space industry to very black and diffuse surfaces used for straight light reduction, for example. Let me now show you quickly the software and the process of measurement. So again, I think it's very easy to use, and that's a key point too. So parameters have to be adjusted first, and then it's a two-step calibration that needs to be done on a reference sample, and then you just replace this calibration sample by the sample you want to measure, and select the angles you'd like to measure, and just let it go. And what you get at the end is both an angular dependency TIS, or reflectance, transmittance, or absorption measurement, together with for each of these individual angle of incidence, the spectral dependency. And I'll finish this new product introduction, TIS Pro, with some specifications. And so what it offers is definitely accurate measurements of reflectance, transmittance, absorption for optical designers. So on top of having solution for what we call BSDF measurements, so angular dependency measurement, now they can go and do together RT and A measurements. So it's fully automated, and again, spectral dependency, angular dependency with very high accuracy. And so that being said, I'll give it back to Epic. And if you have some questions, feel free.
Thank you very much, Quentin. Thank you very much for the presentation. Really interesting and really helpful for production and quality management. And yeah. Let's see if we have some questions from the attendees about your presentation. Yes. Okay, 2 questions. Konstantinas, please.
Hi, Quentin. It was a very nice presentation. I'm really interested if you are able to extend the evaporation spectra to near infrared or to infrared. So, 1.1 micron or something, is it possible? And what the accuracy would be?
So not with the actual solution. We released it like a few days ago, and for now it's only visible spectrum. You may have seen quickly in the spec. It's visible range, slightly before 400 and slightly after 800. The roadmap for that product, before putting near infrared spectral detection, would rather be on putting some options to do also glows and haze measurements. So that would be the next development on that product. And then, of course, the opportunity on the detection side to go for near infrared, but not right now.
Okay, great, thanks.
But what you're asking now is something that we actually do already in our lab. We have near infrared spectral detection, and we can perform those in our lab, but not as a product that you can buy.
Okay, so let's say if I would send you a sample, you could measure it and
sure.
see how...
As a service, this is something we do in near infrared. Now, as for our new product, it's only visible range.
Okay, I think I will get in touch with you.
Sure.
Thank you, Konstantinas, for a question. And another question from Kestutis, ARO, please.
Hello. My question would be, is this tool are measuring absolute absorption. Really? You're measuring reflection, transmission, scattering, and absorption. Are you measuring it, or you are calculating it out of these other measurements?
So thank you for this very interesting question. You get it right. The absorption there is a computation out of the reflectance and transmittance. So I guess that answers your question. It's a computation there.
Yes. All right. Talking about the reflection, then, how accurate you may measure a reflection?
So on reflection, the accuracy that we put on our spec is actually a 0.1% on the white reflectance. Then more than the absolute accuracy when you get to dark surfaces, it won't be a 0.1%. So it depends on the type of samples you would measure.
Okay. Then maybe a last question. Then, what is the difference of this Pro tool, that last one? How it differs from the well-known spectrophotometers in the market, like PerkinElmer or Agilent, who can measure as well reflection, transmission, scattering, everything?
So this is a similar product, let's say, but that we didn't have in our portfolio. So the idea is really to complete the portfolio of instruments that we have and to offer both the BSDF measurement capability, so Reflect, Mini V2 and V Pro, and together with RT measurement instruments.
Okay, thank you, clear.
And you use the same software for all your instruments?
So not really, no. Mini V2 and V Pro share the same software, and then Reflect and TIS Pro would use some others.
And okay, thanks. Thank you, Kestutis, for a question. Andreas Volker from CSEM, please ask your question.
Yeah, thank you very much for the nice presentation. If you can measure all the scattering in all angles, naturally there's a question, could you measure not only from a surface, but also from a turbid colloidal solution to obtain basically scattering profiles as in static light scattering? Would the sensitivity be high enough to do this?
So I guess we could do. Now, if you're talking about the bulk scattering.
Yeah, if you were to put a sample, a fluid sample with a colloidal solution in there, then turbid scattering, and if the angular dependent measurement is sensitive enough, you would be able to deduct directly static light scattering, which could, of course, be an added benefit to your technology compared to the others.
Yeah,
usually don't reach the static light scattering sensitivity.
So the type of measurements that you're speaking about here, we are actually treating those with the older instruments, with the BSDF measurement instruments. We have some capacities to make those measurements, and we've made some papers and that are available. We don't tell everything, but we tell a few things. But we use our other solutions for that.
Okay. So there's no intention to integrate it in this device?
Not now, at least.
Thank you, Andreas, for your question. And okay, if you have no more questions, maybe you can move on. Thanks again, Quentin.
Thank you very much.
Interesting presentation. And let's welcome our next speaker, Konstantinas Zakalskis from OPTOMAN. Please, Konstantinas, you can share your presentation.
Yeah, sure. Second. Sure. Okay. Now we see. Hi everyone. It's nice to open the new season for Epic's new product release. I am Konstantinas from OPTOMAN, and today I will present what new we have in store. This is application optimized mirrors for multipass cells. But first, I want to introduce or remind you what OPTOMAN is and what we do. So, what is OPTOMAN? OPTOMAN is a company of 25 sidekicks that help laser genius to build their lasers. Our mission to be your sidekick for laser optics development and our vision to become #1 choice of laser optics manufacturer worldwide. What we do, well, very easy question to answer. We do laser optics. To be exact, we do laser highly customized application optimized laser optics for high power and ultra fast lasers. We focus only on one coating technology. This is ion beam sputtering, or IBS. I have also an announcement to make. OPTOMAN have a new family member. She's called Wanda, and you guessed it right. This is the third IBS machine, the name of the third IBS machine. Now about the mirrors for multipass cells. I must make a short background why this product is important and what is so fancy about it. MPCs are used for optical pulse compression by spectral broadening in noble gases. This is due to cell phase modulation based on optical Kerr effect. Spectral pulse broadening is a common practice for most of femtosecond lasers. That is how CPA technology works. Though most industrial ultra-fast lasers can reach average power of around 100 watts with optical pulse width of several hundreds femtoseconds. Typically, here is where CPA technology is limited to the gain bandwidth of a laser media. The same rules applies for high-intensity scientific systems that can do broad and limited that we are limited by initial pulse to amplify it afterwards. The main problem here is the trade-off of average power against pulse energy, or vice versa. Using standard gratings or hollow core fiber solutions, you can have both high energy power, high average power, and high pulse energy. This is one of the reasons that limit ultra-fast laser applications in some industries. To overcome this limitation, the MPCs are a perfect solution. The gas are almost optically undamageable. That is why these multipass cells can be used with various setups and increase the intensity of any ultra-fast systems. And the latest scientific papers just confirms what I'm saying now. There are few suppliers that now can supply a commercially available system with this technology, and I'm quite sure that most of new generation high-intensity systems will use MPCs in one way or another. The main catch here is that the multipass cell is as efficient as good the mirrors are in the cell. So what's so special about multipass mirrors? First, mirrors needs to be a broadband. The broader mirror, the broader spectra it can reflect, the better the compression is afterwards. To have a few cycle pulse, you would need a mirror that have a reflected spectra of several hundred of nanometers. Secondly, it must have high reflection and high LDT because optical pulses are making a lot of bounces in these cells, and initially it would be the cell would be inefficient if reflection would be low, and also the pulses, initial pulses on the input have very high pulse energy, so LID must be high. Also, lastly, group delay dispersion, GDT, must be low, and even throughout the whole spectra. This is a vital part because when pulse propagates through the gas, the noble gases induce some DGD, so this needs to be compensated because afterwards, if not, spectral pulse profile could be so terrible that it could not be used afterwards. So, and here is what we have to offer: a field-tested option that, by our knowledge, is the best performance available in the market. We can have a pulse as broad as 200 nanometers. That could correspond to a compression of 20 femtoseconds in near infrared, and reflection of 99.99% throughout near-infrared spectra. Also, the LADT can withstand the very high energy pulses. And of course, we are not stopping here because the market asks for more. There is a need, so we are looking or making the new generation mirrors that will have even broader spectra, reflected spectra, with same outstanding validity and reflection parameters, and of course, special attention to GDP. So that's it from me. I hope this will inspire you to make your new high-intensity system with multipass cell, and if so, you know where to get the mirrors from.
Thank you very much for this presentation, Konstantinas. Interesting. And okay, do we have any question? Yes, from from our workshop of photonics, please, Lukas.
Hi, thank you for the presentation. I have a question about the gases that you use and how long do they last? You mentioned that they are not like permanent. How long do they last?
So, we are making mirrors, optics, laser optics. We're not making the cells itself, but basically by pressure that controlling the pressure, you control the broadening. So basically, these you operate in vacuum and you fill the vacuum cell with gases. So by applying a different pressure, you can change the broadening of the pulse. So.
And do you know how long they last?
I'm not sure, but that's
long enough, I guess. Right?
Long enough.
Okay, thank you.
Thank you for a question. Any other question? Just a question from my side. So you are proposing the whole mirror with the coating, or only the coating on the mirror?
Yeah, we do the mirrors.
Okay, you do the mirrors with the coating and yeah. Okay, and
yes.
And what is the size range you are able to work on? I mean, the minimum and the maximum.
Minimum would be several millimeters, few millimeters.
Yeah.
Maximum would be above 300 millimeters.
Okay. And do you propose some prototyping to customers?
Of course, this is the natural step on going to mass production. So
okay, perfect.
Small batches, then iterations, and
we are going from the yes. yeah. So you are going for the prototyping to the mass manufacturing. Yeah.
We're always looking for long-term partnerships.
Of course. Then okay. Thank you again, Konstantinas.
Yeah, thank you
for your presentation. Thanks a lot. Yeah. And okay, let's move on with our last but not least speakers, Lukas Kulikauskas from Workshop of Photonics. Lukas, yes. Please.
Yes, thank you. Hi, everyone. My name is Lukas. I am software product owner at Workshop of Photonics. And before I start, I have to warn you, my presentation is least scientific from all of yours. I will be very general. Okay, so let me begin by introducing my company. So Workshop of Photonics, who are we? So we are Workshop of Photonics. We say that we deliver solutions to your micron tasks. And we have been doing that for over 18 years in the photonics industry. We've done many things, patents, they have 2 licensed ones. We have a big team of 60+ individuals, professionals with PhD, master degrees, and so on. What do we do? So we can offer you prototyping services. I have to mention that we do over 500 feasibility studies a year. We do production as well. And I guess one of the most important business branches of ours is laser system development. So what does it mean? We can build a system, a femtosecond laser fabrication system according to your application or your need. One thing is missing in this picture, right? So that is no hardware runs without the software. So I am here to answer that question. What are we doing about that? So I would like to present a single control application, or as we call it, SCA. So essentially, this is a software to control your laser machine. And what does it do, right? So your laser machine, the software. So one of the main tasks that we try to achieve is to help your blueprint to become a real fabrication faster, right? Not only we can do that, we can actually help you create those blueprints. So we deliver you tools from research to production and control. So no good software runs without the hardware, right? So what do we do as well? We make sure that all the hardware that you are using essentially is a single, logical, and coherent experience for you to use. Why you might need our software product? So one of the most, I guess, important and overlooked thing is you don't actually need to learn any of the manufacturer specific or universal scripting languages to essentially control the movement of the hardware in the way you like to have it, right? We have created a very simple interface that allows you to use commands that are easy to understand and arrange them into various algorithms in a very natural way. One of the recent additions answering the question why is you want to remotely monitor your system. So we recently introduced an Android application that is available on Google Store that you can download. Unfortunately, to test it, you would have to contact us. But that allows you to see what your machine is doing, when it's going to be done with the current tasks, and what's the status. Okay, when you might want a solution like this. So simple, right? You have a micro fabrication machine and you want to simplify its operations, simplify its use. We also can offer you an interface using Python SDK for now to essentially communicate with other systems. And also we think we are very unique in a way that we are flexible, and we are very eager to learn and do more with less, right? So we can offer you a unique solution if you have a problem that you are unable to resolve. As all good software products, we have to support it, right? So we offer support using a phone or online. We reply the same day. We have a pretty tight release schedule. So we do major updates every quarter. That is pretty major, like a new hardware or new features integrated into our solution. And well, I have to talk about what's next, because that's the most exciting thing for me. So the workshop of Photonics been building laser fabrication machines for quite some time, and the software that was developed in the beginning, it was developed using current day technology. So one of the first really big steps that we are going to do is we want to introduce a new architecture, a new way of thinking how software should work, how quickly it should work, and how easy to maintain. So using some lessons that we learn looking at, let's say, Linux, we think that we, by introducing the new architecture, we can essentially double the rate we can integrate new hardware into our ecosystem. Also, we really want to work with industrialists. And what we did this summer is we create a proof of concept that we are able to perform femtosecond fabrication process using a manipulator arm to automate the placement of the samples and machine vision to align it properly. So we are really want to continue moving toward this path, and we will definitely be expanding our capabilities when it comes to automation. Remote diagnostics is one other feature that we will be introducing next year, hopefully. We visited quite a few shows, expos, in the photonics industry, and this is something that we think is very important which allow not only to use the current features that we have by monitoring the fabrication, but monitoring the system, seeing if maybe predicting maintenance and saving money, obviously. Also, thinking about industrialists, we think about a big system of many machines working together, right? So we are thinking about an ability to consolidate all your systems into one experience that you will be able to monitor. You will get data, analytics, easier planning, and things like that. Well, one of the most important things in our roadmap is the new hardware. So we must expand, right? We have to support the hardware that maybe no one else supports, or maybe you're using and you need help with that, right? So ACS, ScanLab, Kian's, Aerotech's new Automation One platform. So this list is just a small part of what we're planning. Just to give an example, right? So using new integrations with ACS and ScanLab, this year we constructed a machine running on ACS and ScanLab hardware that is capable of working with 2 scanners at the same time, and everything, literally everything, is controlled using our software. So that makes things a lot easier. Also, from our experience with automation, we think machine learning integration for quality control and metrology is also very important. As we are a laser application company at first, right? So we have a big laboratory, and sometimes we have to deal with inspecting the quality of a product that has, let's say, 17,000 objects on it that needs to be checked. So I think a solution like that would make life a lot easier for us and for you if you will be willing to work with us. So a big road ahead. Hopefully, I can position the product as a project, right? We are looking for friends. We want to work with you. We want to hear your ideas, and maybe together we can build something truly unique. Thank you. That's me for now.
Thank you very much, Lukas. Really interesting and useful for this industry. And yeah, let's see if we have some questions from the participant. No specific question. I would like to know if your product is dependent of the laser type. I mean, do you specialize on typical laser, or you can adapt your software on every laser, every type of laser?
Definitely, we can adapt. Though currently we do focus most on the femtosecond laser application, because that's the ecosystem that we are working with, and without the bright minds of our laboratory, we feel like we shouldn't deviate yet. But obviously, if there is a case, we would be more than willing to talk about it.
Yeah, thank you. So you are able to work in close collaboration with your customer to adapt your product on its product. That's it.
Yes, that is true. Actually, every time we are planning something, we always include some of the staff that are working in the laboratory, because, well, who else but they knows best what we need, right?
Yeah, sure.
And every time we develop something, we actually just get one floor down into the laboratory and test it out on the real hardware. So I guess that is a big plus, a big strong point for us. Yeah.
Yeah, right. Sure. All right. Yes, Ulrike, please.
Yeah, maybe I have one question regarding software combination with hardware. So if when you combine your software with the hardware and some special requirements are there, or this is the first question: which requirements do you have to the hardware that you can control it with your software? And if some additional, you mentioned it shortly, interfacing, any kind of hardware is necessary, do you supply it then, or how do you proceed in that way?
Well, as an example, I'll take the fabrication machine that we design and we develop. So what we do is we attach an industrial grade computer running Windows, nothing new, nothing special, and the software, the single control application lives there, and with it you can essentially control the whole system. For this solution to work out of the box, right, we would need to be the hardware that you would be working with. Well, it should be implemented in our ecosystem. So we know that there is tons and tons of different hardware photonics industry is using. That is one of the reasons why we're thinking about a new architecture that would allow us rapidly implement new hardware.
All right.
So just to give a guesstimate, right? If you would come to me and say, hey, we have a machine, we have this controller, this stage, this additional access, this laser, I could say that give us a couple of months.
Mm-hmm. Okay.
And we might do even more than you think.
And you might do
because
that.
In some cases, a good software solution unlocks your hardware.
Yeah. All right. Thank you.
Thank you, Ricky, for a question. Thanks a lot. And thanks again to Lukas from Workshop of Photonics for this great presentation. And if we have no more questions, thanks a lot to all our participants and all our speakers for this today's event. It was really interesting to meet you again after this summer break, and thanks a lot for your participation. And see you soon.
Great, thank you.
Thank you.
Thank you.